So far in our prompt engineering chapter, we learned about what is prompt engineering, and we also learned about different prompt strategies. In prompt engineering, there are different prompt techniques. In this video, we are going to learn zero-shot prompting, which is a very useful technique when dealing with language models. Zero-shot prompting refers to a scenario where you instruct the language model to do a specific task without retraining or providing any examples to the model. Here the language model completely relies on the pre-existing knowledge which it has acquired during initial phase of learning. Zero-shot prompting is the most widely used technique while implementing real-world use cases using language model, mainly because of three reasons. Number one is flexibility. Here model can handle wide range of tasks without needing task-specific training data. Number two, efficiency. It reduces the overall time of your project because you don't need to create your labeled training data, you don't need to pre-train or fine-tune your language models. And number three, the adaptability. It shines in situations where labeled data is very scarce or constantly evolving. These are some of the real-world use cases where zero-shot prompt technique can be utilized, like language translations, sentiment analysis, text classification, summarization, question answering, information retrieval, text generation, named entity recognition, content moderation, recommendation systems, and many more. So without further ado, let us implement some of these use cases using zero-shot prompt technique. Okay, so this is my Jupyter notebook on Google Colab. So here we are going to implement these real-world use cases using zero-shot prompting. First thing we need to do is to create the setup. So let us install OpenAI libraries because we are going to use OpenAI models and their APIs. Then we shall import the libraries. We are using OpenAI API and their model. Therefore, we need OpenAI API key. If you do not have your API key, then you need to create your account on OpenAI and generate your API key first. You can search on Google how to generate OpenAI API key and you will get the required information. I have generated my OpenAI API key and configured it inside Google Colab secrets here. So this is my OpenAI API key. So you can also create your OpenAI API key on OpenAI website and then you can configure it here. Here I'm using userdata.get function to get my API key from the Colab account and storing it in this local variable, my secret key. Now we need to initialize a client for interacting with OpenAI API. So this part of the code is calling the constructor of the OpenAI class from the OpenAI library. This constructor creates a new client object that can communicate with the OpenAI API. Here API underscore key is where you need to assign your API key. Then I have this helper function. Let me explain this helper function. So this line defines a function named get underscore response, which takes two parameters called messages and model. Model is where we are setting GPT 3.5 turbo model because this is what we are going to use. This messages is expected to be a list of message objects formatted according to the requirements of the OpenAI API. So this messages will hold the system prompt and the user prompt. Now let us understand this part of this helper function. This part of the code is where the function interacts with the OpenAI API using the client object. So this is our client object. Using this client object, we are calling chat.completions.create API from OpenAI library. Here we are assigning this model to the model, which is GPT 3.5 turbo. And in the messages, we are assigning our messages, which we are passing here. Then max token, we are setting it to 2000. The model will generate up to 2000 tokens in its response. This temperature, which we are setting 0.2, it controls the randomness of the output. A lower temperature like 0.2 results in more deterministic and less random response, making them more predictable and conservative. And finally, this function will return the content generated by this model, GPT 3.5 Turbo. Okay, so now our setup is ready. Let us try to implement our use cases. So the first use case we are going to implement is language translation using Zerosoft prompting. The task here is to translate any text from one language to another, and we are not going to specify any example to the language model. In the system prompt, we are setting the role for the language model. We are saying that you act as a language translator. And in the user prompt, user is saying that translate the following English text into French. And the text is, hello, how are you? So let us initialize this. And here we are initializing a message list. And in the message list, we are appending the system prompt and user prompt. And then we are going to call our get response function where we are passing this message list. So let us run this. So model is able to translate this sentence, hello, how are you, from English to French. Very well. Now let us try to implement the another use case, which is sentiment analysis. Here the idea is to determine the sentiment of a piece of text. And because we are dealing with zero-shot prompting, we are not going to provide any example to the language model, and we are going to rely totally on the language model to do the sentiment analysis. So this is how the system prompt will look like. So we are going to again set a role for the model. So we are saying you will be provided some text and your task is to do sentiment analysis. And in the user prompt, user is saying analyze the sentiment of the following review. And this is the review user is sending to the language model, which says the product is amazing and exceeded my expectation. So let us initialize this and then put them in our message list and then call get response function. So let us run this and see if model is able to do the sentiment analysis. So the model is saying the sentiment of the review is positive. The use of words like amazing and exceeded my expectations indicates that the reviewer had a very positive experience with the product, which is correct. So this review was actually a positive review. So model was able to do the right sentiment analysis. Now let us see the next use case. The next use case is text classification. Here the task is to classify any text data into predefined category. So here in the system prompt, again we are trying to set the role for the model. So here we are saying you act as a text classifier. Your task is to classify text into following categories. So we are defining these three categories: politics, sports, and technology. And when user provides input, model will try to analyze this user input and try to categorize this into one of these categories. So let us initialize this. And let us run this code. So here we can see that the model has classified this text. OpenAI announced new models under technology category, which is perfectly fine. Here again, you can see that we have not provided any example data, any label data, any training data. Rather, we just utilize the existing knowledge of the model to get this job done. Let us see the next use case, which is summarization. The purpose of this use case is to summarize any piece of text without specific examples of summarization, right? So assume this is a small article. Okay, this article is about some breakthrough in renewable energy technology. So this is the article. And then what we are doing here is that as part of system prompt, again, we are setting the role for the model. We are saying you act as a text summarizer. Your task is to summarize articles. And under user prompt, user is saying summarize the following article, and this article is passed in the user prompt. So let us initialize this and now run this piece of code. So here this system prompt and user prompt are appended into this message list and sent through this getResponse helper function, and this is the response we are getting from the model, and this response is printed. And this is the summarization of the article. Perfect. Let us move next. The another use case for zero shot is question answering. Now here the task is to answer question based on a given context without seeing specific question answering pair. So basically, again here through system prompt, we're trying to set the role for the language model. We are saying you act as a question answering chatbot. Your task is to answer user question based on given context without seeing a specific question answering pair. Okay. Now let us ask any general question. So we are saying, what is the capital of India? And then the same piece of code here now let us execute. So we can see the model is responding saying the capital of India is New Delhi. The next use case is information retrieval. Information retrieval is again a very important use case, very good use case for real world scenario. This is also called RAG, so retrieval augmented generation. This is where this zero shot prompting is used. Here, imagine you have this text corpus. So this is your text data. So this is again a sort of article. There is a title and then there is this text description. This article is about the history of internet. Let us initialize this text corpus. Now, in the system prompt, again, we will set the role for the language model. So here we are saying you act as a question answering chatbot. Your task is to answer question based on provided context. Based on provided context, and here we are passing this corpus. Okay. And we are also instructing the model that if answer is not available in the given context, then just say I don't know. Now, the user question is, what was the original purpose of ARPANET project? Now, let us first manually check whether the answer could be derived from the provided corpus. We can see that this corpus is about history of internet and it has content related to this ARPANET project. So we are expecting that model should provide the response from this text corpus. So here we can see it says the original purpose of the ARPANET project was to create a network that could survive nuclear attacks and connect various research institutions. And this is exactly what is also mentioned in this article. So perfectly fine. So for this information retrieval use case, model is able to derive the answer from the provided context. Now, here we have also set an instruction that if answer is not available in the given context, then just say I don't know. Let us verify this part. So here, now we have just changed the user query. Now we are saying what is the capital of India? Ideally, this time model should say I don't know, because in the provided corpus, which is this one, there is no mention of India and what is the capital of India, right? So model should say I don't know as per the user instructions. So let us run this. Very well. So it says I don't know, which was expected. Now the next use case is text generation. Now generating text based on a given prompt without a specific example of generated text is very useful when you are writing some stories, poems, books. So for any content creator, this use case is very important. Now, again, through system prompt here, we are trying to set the role for the model where we are saying you act as a story writer. Your task is to write a short story. We are also saying that in max 10 lines on provided topic. So now through user prompt, user is asking the model to write a short story about a dragon who learns to fly. Let's initialize this and run this piece of code. So now the model has written a short story on this subject. Very well. Now the next use case is named entity recognition. Here the task is to identify entities in a given text. Entities could be anything like names, dates, location, date of birth, your mobile number, email ID, anything. So here in the system prompt, we are again setting the role for the model. We are saying you act as a named entity recognition system. Your task is to identify entities like names, dates, and locations. And through user prompt, here is the user instruction. So user is saying, identify the entities in the following sentence. And this is the sentence which user is passing. So let us initialize this and run this. And this is the response we are getting, which says entities identified in the sentence is name John, location Paris, date June, which is correct. So these are the entities in this sentence. Another use case is content moderation. Here in the content moderation, the task is to identify inappropriate content in a given text data. So again, here in the system prompt, we will set the role for the model. So we are saying you act as a content moderation system. Your task is to identify inappropriate content. And through user prompt, user is saying, is the following comment appropriate? You are so stupid is the comment. So let us see what is the response from the model. So here model is saying no, the comment you are so stupid is inappropriate as it is insulting and disrespectful. It is not constructive and can be hurtful to the person it is directed towards. Excellent. Now the next use case is recommendation system. Now here the task is to recommend items, could be music, movies, books, based on user preferences without explicit examples. So here through system prompt, again, we are trying to set the role for the model. So we are saying you act as a recommendation system. Your task is to recommend a movie based on the description. And in the user prompt, user is saying, recommend a movie based on the description. And this is the description for which user wants this model to recommend a movie. So let us run this. And this is what model responded saying, I recommend the movie Interstellar, directed by Christopher Nolan. It is a science fiction film that involves space travel, exploring different planets, and dealing with complex scientific concepts. So based on the user input, it has recommended the movie. Okay, so we have implemented many real-world use cases using zero-shot prompting. Before we conclude, I would like to mention one thing, that while implementing any use cases through zero-shot prompting, you should always apply first to prompt engineering strategy, which is writing clear instructions and breaking your complex task into smaller subtasks. Okay, so this is all about this lesson. In the next lesson, we are going to talk about another prompt engineering strategy, which is one-shot prompting.